Well, everyone, thank you so much for joining us for today's event. This is the Melbourne Connect event, the Connected You material creation, and really excited to have you all here for some really interesting topics that we're going to dive into. Some people have been joining, and there's been mention and reference to references being shared throughout. So I'll put those in the chat as we go, based on some of the topics of conversation that come up in the presentations. Before we dive into the event today, just as I begin each event, I'll begin with an acknowledgement for the traditional owners of the land that we're on today. From where I'm presenting, it's the Wurundjeri people of the Coghlan Nation, as well as obviously the traditional owners of the land that you're situated on, and acknowledge that Indigenous Australians have been custodians of the lands and waterways of this country that we call Australia for thousands of years. So we pay our respects to their elders past, present and emerging, and use that as an opportunity to welcome you all here for this really exciting lunchtime event. We know that it's online and we would love to have these discussions in person, but it's really heartening to see people turning up and really engaging in these pretty thought-provoking and sometimes right out there topics. But the reason is to highlight some really incredible research and initiatives being created all around the world, and particularly within our base here in Melbourne. So can't wait to share all that with you. My name is Garry Williams. I'm the creative producer of innovation as part of University of Melbourne, delivering this event for you today. And this event series, The Connected You, is a monthly presentation style event focused on the relationship between humans and technology in its many different iterations. So we're talking about material creation today, an element of which is our capacity to produce unheard of developments in manufacturing. We'll dive into advanced robotics, high performance computing and much more. I'll leave the speakers to summarize that adequately. But for a little bit of context, I'll share some slides about what Melbourne Connect is and what types of conversations we're driving. Allow me to just share that for 1 second. There we go. I've stopped asking whether you can see my screen and just presume that you can. But if you have trouble seeing the actual presentation, if you scroll to the top of the screen and select view options, you'll be able to select fit to screen for your convenience. So we're here for material creation. This is Melbourne Connect. It's opening in 2021. It's a purpose-built innovation precinct launching on the corner of Swanson and Grattan Street, which is basically the site of the old Royal Women's Hospital. It's going to collate industry, researchers, collaborators, students. We're going to have the Melbourne School of Engineering in there, Science Gallery Melbourne, which you can see pictured on the corner there, which will engage 15 to 25-year-olds in developing a passion for STEM-based subjects. And of course, other initiatives such as Melbourne Accelerator Program, translating research at Melbourne and so on. We're going to have multiple bespoke spaces, and this is a heavily designed innovation precinct, which is essentially a development partnership between University of Melbourne and Leins. We're going to have many events in person, but basically along the flavour of what we're discussing here today. And essentially lots of spaces within there for us to gather when we can, again, gather in person. We have much public space, and there's a number of technologically enabled factors relating to this, which we're really excited to unveil. But for the purposes of today's conversation, we're here for material creation, which is a very exciting one. Now, I have here some mentions of Dr. Kobe Lyons and Dr. Simon Coghlan. That's not a typo. They're each a senior research fellow in digital ethics as part of the Centre for AI and Digital Ethics. But each of the doctors today will have different, elements of adhering to the theme of material creation, which they'll address. I'm going to very quickly do the formal thing for each of you and read out, your bio and background to add some context for our attendees today. But of course, you'll dive into that in much greater detail after. So Dr. Kobe Lyons has managed programs and teams in the areas of administrative law and justice, humanitarian law, human rights law, and disarmament with the United Nations and the International Committee of the Red Cross. In 2006, she worked with the International Service for Human Rights in New York to advocate for the adoption of the Declaration on the Rights of Indigenous Peoples, after which she worked for the United Nations Secretariat In 2005, she liaised with state scientists and stakeholders to raise awareness of and compliance with the Biological Weapons and Chemical Weapons Convention. So thank you very much, Kobe, for joining us. I can't wait to dive into a lot more of your talk today. Again, thank you for being involved again, I should say. And Dr. Simon Coghlan, he's a moral philosopher and a veterinarian. He's a senior research fellow in CAIDE, as we affectionately call it, which is a part of the School of Computing and Information Systems, I should clarify. He previously worked in university medical schools, teaching and researching in health ethics. And before that, he was a small animal veterinarian in private practice. His research in digital ethics includes a focus on social robots, on animal-computer interaction, and on digital technologies in healthcare and public health. He has interest in applied ethics of various types, including conservation ethics, animal ethics, and medical ethics. So I've done the part of doing the formal readout of what you do, and I'm delighted to have you both here. Thank you for joining us. Before we launch into the presentation, how's everyone doing? I'll take that as good. But last bits of housekeeping from me before I leave it to Kobe to kick off today. We've got Zara Zainal joining us. She's doing the graphic recording today. Thanks once again, Zara. The graphic recording is an incredible storytelling technique, and we love that to embed that in a number of our activations. So thank you, Sarah, once again. We're recording this conversation. We're going to publish it on YouTube at the conclusion of this event, usually within a few days. We'll include that graphic recording as part of it. This event will go to 1:30 p.m. maximum, and you're very welcome to pose questions in both the Q&A function at the bottom or the chat function off to the side. I mentioned again, and I'll do it again, but there's a number of references that Kobe's provided and that Simon will reference. I'll put them in the chat so you can reference them yourselves, and I'll also include that in the YouTube description as well, just to add a little bit of weight behind that context again. So that's enough from me. I'm basically going to take the questions and curate them at the conclusion of each presentation. We're going to go with Kobe first and then Simon. So hold tight, Simon. I can't wait to hear your presentation. Kobe, thank you very much for joining us.
Thanks so much, Gary. I'm actually going to flip this to keep you on your toes. Simon's going to lead today, and he's going to start by talking about the macro materials, and I will then move to the micro and the nano. So we're starting at the biggest possible scale, and then we're going to come back down. So I'm going to hand over without further ado to my wonderful colleague, Simon. Thank you.
Perfect. Thank you.
Thanks, Kobe. Throwing a curveball there at Gary. Well done. Now I'm just going to share my screen. Yeah, share my screen there, Gary. So I am going to ask you whether you can see this or not. Does that come up?
Yes, can see it. Thank you.
Good on you. Right. So the topic of the heading title of my talk is Cruelty and Kindness to Social Robots. So what I'm interested in chatting about is social robots, and in particular how they might affect us or influence us or shape our own behaviour. So to set the scene, robots have clearly been a part of human popular culture and art over the last 100 years or so. These are just some of the more recent examples of various robots in film and television, which are all quite interesting and have different kinds of relationships with the human beings in these programs. So what I'm going to talk about is social robots, and I'm going to distinguish the social robots from things like industrial style robots. So social robots are robots that occupy social spaces, domestic spaces, say in the home, at the shops, and so on. These are robots that might have social features or qualities. And in particular, I want to talk about the kinds of social robots that look something like human beings or animals, and also behave something like human beings and animals. So they might not be quite as realistic as the robots that you see in a program like Westworld, but I'm thinking of robots that behave something like and look something like perhaps humans or animals. And the kind of robots I'm thinking about are robots that have autonomous capabilities. So these are robots that can act, as it were, on their own without needing continuous human input. that follow pathways that might be hard to predict, perhaps. So I'm talking about autonomous robots with a kind of autonomous repertoire of behavior. They can still be fairly simple, but they have some degree of autonomy. Right, so robots are found all over the place now, and increasingly so. So robots might be found at least in certain countries, in sort of public service or customer service roles. And then you have robots which are more companion-style robots. So here's quite a famous example of a robot called Pero, which is a baby robot harp seal. And here's a picture of me looking very awkward with this baby harp seal, because while I'm a veterinarian, I don't usually treat robots, or seals for that matter. My colleague here is Jenny Waycott, who studies robots and their relationships with sort of older people, or older people's relationships with them. And the fellow in the middle of the screen is the person who designed Pyro. And what was interesting about this encounter with Mr. Shibata was that he showed us how Pero behaved, and then he invited us to hit the robot, to strike the robot, to see how it would respond. And it turns out that the robot responds with a kind of a cower and a whimper. So it actually has this feature built into it that it allows you to be cruel to it or nasty to it. And so that piqued my interest somewhat in the kinds of things that robots might be capable of, and and the kinds of ways that they might start to influence us or shape our own behavior. So Paro has actually become quite famous. He was involved in a Master of None episode. So Paro, the companion seal, has also entered into popular culture now. Well, I just want to address the question of why should we care about this movement of social robots into our lives. And I guess one of the reasons why we might think about them or care about this phenomenon and how they might affect us as human beings is that there is likely to be growing demand for robots. So robots might be used to care for people. Say with the aging of the population in particular, robots might be used to care for older people. And they might be used increasingly as companions for people who, say, can't have an animal, or people who are lonely. Another reason for getting interested in robots, social robots, I guess, is that we can expect that there will be quite great advances in their capabilities. So as artificial intelligence gets more sophisticated, and as robotics itself becomes more sophisticated, we can expect robots to behave in more and more interesting ways, autonomous ways. And lastly, I'm interested in social robots because of the philosophical implications, I guess. So I'm interested in what kind of relationships we can have with machines, as well as with humans and animals. What kind of relationships can we have with social robots? Now, I should say that some of what I'm talking about here, I'm drawing on a paper that I wrote in the International Journal of Social Robotics. And there I talk about this Montreal Declaration for Responsible Development of Artificial Intelligence. And one of the things that says is that, one of the principles it has is that artificial intelligence design ought not to encourage cruel behavior towards robots that take on the appearance of human beings or animals and that act in a similar fashion. And so you might ask, why would that be the case? Why were they worried about designing robots that you can be cruel to? And one of the reasons is that that if we're cruel to robots, it raises the question of whether that will make us crueler towards human beings or towards animals. So it raises the question of whether there is a causal link between the way we treat robots, the robots of today or the robots of the future, and the way that we might treat or relate to human beings and animals. But a big problem with this notion of a link between these two things is that there seems to be a complete lack of evidence, or a relative lack of evidence at least. That is, no one's done a big study to show that if you're cruel to robots, then you're more likely to be cruel to human beings or to animals. There's a bit of lack of evidence. So what are we going to do about this? What are we going to say about this question in the absence of but kind of solid evidence? Well, what I will do is just raise a few considerations that might be relevant to determining or thinking through whether there is likely to be such a link. Let's start with a case for thinking that there is a causal link between cruelty to robots and cruelty to living things like humans and animals. Well, first of all, as I mentioned, robots are going to get more and more lifelike. So as they get more and more lifelike, they more and more closely resemble the humans and animals that we think we ought to treat with respect. Researchers in the field of robotics also tell us that we have a predisposition as human beings to anthropomorphize non-human things, and that includes machines and computers. So some researchers have shown that, strangely enough, we tend to be more polite, even without thinking, towards computers. We adopt certain kinds of language and so on towards them, which you would perhaps not expect that we would adopt towards a mere machine. And another reason for thinking there might be a link is that we seem to have quite strong affective responses to robots. So the example I've given here in the picture is an example of it's kind of a way out example, but it's interesting, of a robot dog funeral, a Buddhist funeral for these defunct Sony robot dogs that people could no longer use and wanted to send off in a certain way. So there seems to be the possibility of interesting, perhaps strong, affective responses to robots. So another reason for thinking that there might be the link of the kind that I'm talking about comes from the philosopher Immanuel Kant. He, of course, doesn't talk about robots, but he talks about animals and our treatment of animals. So I'll just read out this quote to you from Kant. It's quite a famous quote, actually, within animal ethics. So Kant said, if a man shoots his dog because the animal is no longer capable of service, he does not fail in his duty to the dog. But if he is not to stifle his human feelings, he must practice kindness towards animals. For he who is cruel to animals becomes hard also in his dealings with men. So here the obvious idea is that, that the same thing might apply to robots. So that is, if we're cruel to robots, perhaps we'll become cruel towards humans or towards dogs or other animals. So that's Kant's thought. But now let's consider the case against thinking that there might be a link of the kind I'm talking about. Well, first of all, we have been playing violent video games for some time and watching violent movies for longer. And there is really quite equivocal, or even some would say weak evidence, that that doing those kinds of things, engaging in those kinds of violent behaviours, has any effect on our relations to human beings, has any proclivity to make us more cruel or more violent towards our fellow humans. And secondly, it's evident that these robots that we're talking about, these social robots, are not sentient. They don't have any feelings. They literally cannot suffer. So that raises a quite a serious problem, perhaps, for this position, and that is that it doesn't even seem to be possible, given that robots can't suffer, to be cruel to them. So we talk about cruelty to robots, but in a sense we need to put cruelty in inverted commas, because it looks like it's conceptually impossible to be cruel to something which literally cannot suffer. And for the same reason, it seems to be impossible to be kind towards a thing which has no feelings. Furthermore, it looks like while we might anthropomorphize robots, it's not exactly clear that we're fooled by them. So we might act as if we are attributing certain qualities like feeling to them, but in fact, it may be the case where we're not fooled at all about what's going on. Maybe we're engaging in some kind of make-believe in response to them, but we don't literally believe that robots can suffer. Well, I wanted to come back to Kant to address this question. There's skepticism that cruelty, in inverted commas, towards robots might rub off on us and cause us to be more cruel to humans, or less kind, at least, to humans and animals. So Kant also had this thing to say about not dogs this time, but insects or grubs. And if we take grubs or insects to be non-sentient creatures, it's quite interesting what Kant says about it. So Kant's talking about his friend Leibniz, and he says, I'll read out this quote. Leibniz put the grub he had been observing back on the tree with its leaf, lest he should be guilty of doing any harm to it. It upsets a man to destroy such a creature for no reason, and this tenderness is subsequently transferred to man. So perhaps what we can draw from this quote is that it looks as if it might be possible after all to be cruel or kind or tender and so on towards things that don't have any sentience, any feeling whatsoever. So therefore it raises the question of whether we can in fact be cruel to robots after all, or kind to them. Now here's an example that some people have talked about, but it suits our purposes quite well. It's the example of a mine removal robot that was designed in the US. And the journalist reports the following. They say every time this insect-like robot, and it has 6 legs, every time it found a mine, blew it up and lost a limb, it picked itself up and readjusted to move forward on its remaining legs, continuing to clear a path through the minefield. Finally, it was down to 1 leg. Still, it pulled itself forward. The colonel ordered the test stopped. This test, he charged, was inhumane. Well, the suggestion here is that perhaps it is possible to be cruel to robots. It is possible to be humane to them. And I don't want to sort of say one way or the other on this, but what I would say perhaps is that it looks like we can be, if not cruel to robots, then something very akin to that, something very similar to cruel to robots. Actually, there have been some experiments which have tested people's responses to being cruel to robots. These are kind of robot torture experiments in which people are asked in the experiment to torture a robot like this, this robot dinosaur here. And some people were actually quite reluctant to do so. So it seems as if they had this sense that that doing these things to the robot was cruel or callous. You may have also seen these quite popular videos on YouTube of people from Boston Dynamics hitting and pushing over the robots that they've designed to show how they behave. And these robots fall down and struggle to get back up again. So I've kind of suggested, and I'm coming to the last slide now, that it looks like there's something very interesting going on in our relationship to these autonomous machines, and particularly more so as they get more and more lifelike. And this raises the question of whether there might be a causal link between our treatment of them and our treatment of humans and animals. So it looks like if robots are becoming more and more interestingly lifelike, then they're going to engage our effective responses increasingly. And these are responses, as I've said, that look a lot like cruelty and pity and tenderness and kindness and so on. And these robots, as I've already indicated, are going to enter our lives more and more. So they're going to be, potentially be anyway, unless we reject them, our carers and our companions. So it may be that the children of the future are going to grow up with robots that are companions, sophisticated autonomous robots that are companions. And given that children are very impressionable and are still developing their moral characters, it does raise the question of whether they might be more affected by the way that they interact with robots than even adults would be. And to finish with, if we design robots that resemble certain kinds of individuals in society that tend to suffer discrimination, and perhaps we could think here of women and people of colour, then being cruel to those individuals seems to raise some concerns. Being cruel to robots that are made in their image seems to raise certain particularly acute concerns, given that those individuals are already discriminated against or marginalised in various ways. And finally, if we're creating robot animals, which are very popular, animals too are not very well protected by society. So if we grow up with robot animals that we're cruel to or kind to, perhaps those kinds of behaviours would rub off on us in interesting ways. And that brings me to the end, so thank you very much.
Well, that was absolutely fascinating, Simon. Thank you so much for that. I've got a wealth of questions, but of course, please, anyone do pose them in the chat or the Q&A function, because we're not here for ages to ask the questions per se. Let's go into some of those concepts. I'm really fascinated. I think we'll leave the questioning with a segue into what Kobe will speak about. But I have noticed, obviously, I mean, say if we're talking about the Boston Dynamics example, that felt like highly shareable visuals. That also, it seemed, I guess, some of the public sentiment to be able to, I guess, remark on, being that Google, I think, owned Boston Dynamics, it sort of went against their ethos of, Google doing good, and it felt like a good way for people to sort of make comment on the responsibility of corporate entities, essentially. How have you sort of seen, I guess, you've mentioned a lot of pop culture sharing or proliferation of these sort of sentiments in wider society. So how have you sort of seen, I guess, social media play a deep role in sort of thinking about people's reactions to seeing visual cruelty towards robots?
Yeah, thanks, Gary. It's kind of an interesting stage because actually the Boston Dynamics video has been lampooned. I don't know if you've seen a video showing that. A comic version of that. And I guess what something that's interesting for me about that is about the whole Boston Dynamics thing is that that it's quite unclear how we should react to it. I mean, we can react in certain ways. You have certain responses to these things, but I find myself thinking, is that the appropriate reaction to have? And so I think, and some people clearly don't have that. At least don't have a very strong reaction of that kind, and just think it's kind of a little bit silly to be talking about being cruel to robots or to other machines. And so I'm sympathetic to that notion. But it's also, I'd say, it's very interesting that people do have these responses and do talk about it on social media and so on. That they do worry about it and think that it's perhaps going a little beyond the pale. Yeah, and people have even worried about this in relation to things like, Google Home and Alexa, Amazon Alexa, and people talking to those home assistants in kind of derogatory ways or offensive ways. And it's perhaps made more acute by the fact that that sometimes, well, often these voices are female voices. Yeah. And so that's why I wanted to raise that in that little chat that I just had about the prevalence of things like sexism. And Kobe quite rightly points out that Kant was entirely vulnerable to that because he talks about men and not women. So there are interesting things at play there. And I with the robot question, I think that I would certainly be more concerned about people enacting cruel behaviours towards members of minority groups that are represented in robot form than being cruel, say, to a white male-looking robot.
Yeah, absolutely. No, I totally understand you. One of the guests or attendees today made mention of TV shows like Robot Wars, in which robots are designed to destroy each other, making a case for the case against, I should say. Let's go into, I mean, on the mention of digital assistants, Professor Jeannie Marie Patterson spoke on the last Connected You event, which had reference to home. So we were talking in a different context, but we've drawn some parallels between the two events in that regard. And she's obviously, the co-director of Centre for AI and Digital Ethics and one of your colleagues, which is fantastic. I'd love to know the interplay between yourselves, and we'll get into your direct correlation to Kobe's research, but between yourselves and your colleagues involved in CAIDE, as we call it, how many of you are involved within the initiative? How much interplay is there between each of your respective research pieces, or works, I should say?
Yeah. Did you want to answer that, Kobe, or shall I go?
Oh, I'm happy to jump in. So we're a team of 3 senior senior digital ethics research fellows, and we sit within the School of Computing and Information Systems, but that centre straddles law and computer science. So what's amazing about our roles is that we're embedded with people who are programming, creating computer vision, human-computer interaction, which is some of the work that Simon's been involved in, and also some of the most cutting-edge AI. So instead of sitting in another faculty weighing in on what's happening in this faculty, we're actually embedded, which is amazing. So by background, by way of background, I'm a lawyer, and Simon and Mark are ethicists, which is it's a truly incredible capacity, and I don't know of anything else that's similar in Australia at the moment.
No, I had someone remarked to me that they did their PhD in the wrong era, and would have loved to have gotten involved. Another parallel, actually, before I leap into this question for you, Simon, I would love to ask you maybe a little bit about your career pathway, because you have a background in private practice. That you're a private practice veterinarian. How did you progress into this sort of line of research and work?
Yeah, well, actually, it did come about through the through the robot animal example. So I was interested in relationships between human beings and animals as a veterinarian, because that's what I saw every day, people's relationships with their animals, and how significant that relationship can be, and how attached people get to their animals and treat them as family members and so on. So that always interested me, but also interested me as a philosopher as to what kind of relationships we ought to be having with animals and how we ought to be treating them in society. But the I guess by chance I came across people in HCI, in particular Jenny Waycott from CIS, who were doing some research in this area, and they were looking at the use of robot animals as companions for older people, and that and because older people often can't take their animals into aged care, and that is perhaps particularly interesting at the moment, given how lonely people can be during lockdowns and quarantines and so on during the COVID crisis, how isolated people are actually. And so I was interested in what kind of relationships older people might have with machines, with robots or with home assistants and so on. So that was a natural kind of progression from looking at how humans interact with other non-human individuals, i.e. animals, to looking at how humans might behave in response to robots,
fascinating,
and how that might shape us as human beings.
I'm going to lean on the companion piece a little bit. We mentioned about Melbourne Connect. Obviously, Science Gallery is within there, and their 2018 exhibition Perfection talked about concepts of perfection, and one particular exhibition piece was a sex robot named Harmony. So, I don't need to sort of dive into it in huge detail for now, because we're going to run out of time if we do so. But I'd love to know, have you been sort of exploring some of those companion contexts of late, and does sort of, I guess, COVID-19 have any bearing on changes or alterations to some of your research directions, in a matter of speak?
Yeah.
Does it influence the research, and does it change some of the hypotheses essentially?
Yeah. Well, I'm going to bypass the whole sex robot thing. That's actually that's what's fascinating, but it's not what I've been primarily looking at. But I think it's very much related to it, because it's interesting that some people have been discussing this recently, that it may be that the case that some of the more dubious kind of relationships or behaviors that can happen between men and their sex robots are very interesting, in terms of, like, is some of that behavior, particularly if it's abusive, in what way is that problematic? I mean, we tend to think that it is problematic, but I'm interested in why that is the case, and how do we explain that kind of thing. But so that's really interesting. But I guess my next bit of work will be on the nature of companionship. So I'm very intrigued by the question of whether robots can be companions at all, and if they can, what kind of companionship is that, particularly given that they're in one respect, completely unlike animals. That is, they have no inner life, they have no feeling. So in what sense can they be companions is something that that is very intriguing.
Yeah, fantastic. Look, let's end it with one last piece. I'm going to sort of, I guess, imbue the segue into Kobe's talk. Let's talk about research that you're working on together. This gives me an opportunity also to start putting in some of those, I guess, co-authored pieces of research into the chat. Let's talk about what you're working on together. There was mention of Xenobots and other types of work at the moment that Kobe mentioned. Did you want to remark on that?
Yeah, actually, that was really interesting work that Kobe and I did together a few months back when Xenobots came on the scene. And Xenobots are, very briefly, tiny little quasi-organisms, very, very small, that have been designed by supercomputers. And so they're called Xenobots. So they're actually made of living material, but they have a robotic dimension. In the sense that they've been programmed to behave in certain ways, have been assembled in order to behave in certain ways. So Kobe and I were fascinated by that invention. And look, it may be that the science doesn't go anywhere, but the reason why these things were being designed was to see what we can do partly to see what we can do with living creatures, with living material, and how we can alter it and shape it and make it fulfill our aims, perhaps. So I don't know if that's a segue there to Kobe, because you might have been going to mention Xenobots as well.
No, that's perfect. And thank you so much, Simon. We really appreciate it. I can't wait to talk about a lot more of your research in future activations, but I really appreciate your time being involved. You've inspired, as Kobe remarked, for Zara to put the very first robotic seal on one of our graphic recordings. So we're all very excited. We're all very excited over here on the internet. Simon, thank you very much. Kobe, over to you. Let's kick into it.
Thank you. Thank you so much, Simon, for that fascinating talk. I'm going to see if Zara can put more robots on this presentation than any other drawing that she's done before to add to the seal. And I'm looking forward to seeing how Zara manages what I'm going to talk about, which is materials at the very, very small scale. And in particular, as you've opened with this talk about Xenobots, the reason that I was interested in Xenobots is that my doctoral research was actually on nanomaterials. And for those who don't know what that is, it's the teensy tiny material that you cannot see. So if you think about the size of an apple to the size of the Earth, that's the sort of scale that we're talking about. A nanometer particle would fit 80,000 times across a human hair. So rather than the macro, fluffy seal, cute type science, what I wanted to talk a little bit was about the history and the imaginaries around this type of science, because it hasn't just emerged out of nowhere. And in the research that I did for my PhD, I was looking at specific applications of these materials in a wartime context. So how could they be misused? How could they be used for hostile purposes? And then what was the international law that was governing the use of these materials? So when the headline came out that Xenobots, which are called Xenobots because they're taken from a frog called Xenopus levis, I was absolutely fascinated. And again, Simon, as an ethicist, has an amazing insight into a completely different angle to how I would approach this. So the news hit the headlines. I think it was early 2020. It's hard to remember now, Simon. It feels like, well, maybe it was even late 2019. It feels like years ago now. But basically, as Simon's already foreshadowed, these cells were taken from frogs. But what was really interesting about this particular process is that it was expedited using extremely high-level computing. So the computers were looking at these cells and seeing what properties they wanted to get, and then basically manually putting together cells that wouldn't occur in nature, given the properties that they were looking for. So the use of computers to predict or expedite the efficiency of cells is not new. This is something that's been done for many, many years. But I think what was new in this particular instance was that these cells were then manually put together and that they stayed alive for a number of days. So of course, Simon and I jumped on this, and thanks, Garry, for putting up some of those links. I started to write a little bit about what it would actually mean to use algorithms to create life. What is it that we are trying to do? What is it that we want to do? And I'm going to go back to the beginning of where I was going to start in this talk before I was led in by the Xenobots. And that's to say, I was going to use a quote that I heard this week that really resonated. And it's, who controls the past controls the future, and who controls the present controls the past. was said in relation to Black Lives Matter. I'm going to say it again. Who controls the past controls the future, and who controls the present controls the past. And the reason I'm starting from this point is that I'm going to go way back in history. So when we first started to imagine what these beings could look like, because we had a vision. Humans have wanted to replicate themselves and wanted to recreate themselves for as long as we can remember, but we have some really interesting documented cases. The first case, which is probably the best known of all and which will be very familiar, and I hope it shows up in the graphic, is Frankenstein. So Frankenstein was, what many people forget, was actually a biological sentient being. So Mary Shelley spent a summer in Geneva with Lord Byron. It's a lovely story. And she was inspired to write this book about this modern Prometheus, this modern creation of humans that didn't go quite right. We all know the story of Frankenstein. And if you don't, definitely go back and read it. It's a fantastic read even now. Lord Byron, what many people don't know, and this is a little bit of a footnote, but I'm going to say, hang on with me through this journey because it will come back to Xenobots in a strange way. Mary Shelley was friends with Lord Byron, who actually had only one daughter that was in wedlock. And for some of us who know about computing, we will know that that one daughter was Ada Lovelace. Ada Lovelace never met her father, Lord Byron, but she went on to create what was considered to be the first computer. So we have this lovely weaving in of a conceptualization of a, we didn't even have the word robot yet, and I'll come to that. We had this relationship that resulted in an amazing piece of literature. And then we have a child who's born who then goes away and imagines the analytical engine, arguably the very first computer. If you skip forward 100 years, I told you it was going to be a fairly fast ride. We're now in 1920. So we're between the wars. We haven't seen a lot of the technological advances that we are now familiar with, or many of them. And the first time that the word robot appears, commonly used, was in a book which is far less well known, and it's the back of the, it's actually a play in the background. This is my background here. It's called Robertum's Universal Robots. And robot is merely the word means the word worker or serf in Czech. And to be fair, Čapek gave credit to his brother for this word. Before that, we'd talked about automatons, we talked about androids. But again, what's really interesting about these robots is that they weren't metallic. They weren't a fluffy seal. They were flesh and bone. And Helen, the primary character, the protagonist, who has all these concerns about being overthrown by the robots, which in effect, in the end, does happen because we have this lovely need to catastrophize what robots can do, as well as fantasize about their possibilities. Helen was this female protagonist who really raised concerns. But in this book, there are descriptions of kneading troughs for robot skin. They had great vats for livers and brains. These were not hard steel robots. There was already this vision of there is going to be an ability to manipulate matter in a way that could potentially come back to harm us. And we have to keep in mind that this is 1920. It was only in the 1950s that we started to understand DNA. So incredibly visionary and an amazingly well-written and fascinating read for anyone who's interested. Around the time, the 1950s, we discovered what genes could do. We started to understand biology, very, very basic biology. And I'll just drop in as a footnote, 1956 was when the AI Dartmouth conference was, which is often flagged as one of the founding moments of AI. So we sort of have this rolling capability. So we've got the ability to understand biology on a very basic level. We've got this fantasy about what we think AI is going to be able to do, a conference that ran over 6 to 8 weeks, which was populated by nearly entirely all men, and only one behavioral scientist, who was Skinner, who thought that humans were just like robots anyway. In 1959, there was an off-the-cuff presentation by a man commonly considered to be a genius called Richard Feynman. And at a Caltech presentation with no notes, off the cuff, he started talking about matter so small that we wouldn't be able to see it, but it would be able to change the world. And only because someone in that lecture had a recording device and managed to document it is this speech now available online. It's an incredible speech, an incredible vision, when there was no science to back it up at all yet, that we would be able to manipulate matter. And when we're talking about nanomaterials, the reason this links back to the genetic conversation, the conversation about understanding genes, is that most of our bodily functions happen within our cells on the nanoscale. They're tiny scale. if you think about enzyme exchanges or cell reproduction, or even the antibodies or viruses that we're affecting our lives every day, they're all happening at the nanoscale. So this is a really important moment where the possibility was opened up, and then it was forgotten. Feynman was not referred to again until the 80s, when nanotechnology started to take off. And I say technologies because the nanomaterials, as they're generated, result in very different outcomes to materials at the regular scale. So if you take a silver molecule, for example, and it's at the nanoscale, just because of its size, nanomaterials often have increased surface area to mass ratio, so they have a larger surface area, a greater permeability, they're often stronger, they might have different chemical properties, and in some cases, like silver, at the nanoscale, they're actually can be quite toxic. So we've got this research area where we're looking at science being developed and human body functions developing rapidly. We've also got an increased capability in AI, which then brings us full circle back to the introduction that Garry and Simon gave us so well, which is, how do we bring those two together? And what I'm really interested in is where fields intersect, because we often specialize. It's a trend in academia generally. We tend to go into silos of what capabilities are. And the really amazing breakthroughs are often across different disciplines. And so the Xenobots piece was a really interesting joining of these two developments, of this amazing ability to compute, amazing understanding of biological material. And I would argue it's only just the beginning. It's the first step in what we'll see of many more similar developments. And this is where my interest comes in. We don't necessarily have the governance frameworks. We don't necessarily have the ethical abilities. Certainly most people don't have the abilities that my colleagues have to say, hey, hold on, whose interests are we serving? What are the rights of these organisms? What if they do reproduce? What if they are going to, there was this fear of grey goo when nanomaterials were first talked about. What if they take over, which I don't think is going to happen. But there are many, many more sophisticated questions. And more broadly, one of the things that I'm really interested in and that we talk about a lot in our team, computing power with increased data is enabling us to expedite processes and to materialize not just biological material, but also other realities in ways that we just couldn't have even imagined 5 or 10 years ago. And all of those developments raise legal and ethical issues that we really need to be thinking about, not individually, not separately, but in conjunction and across disciplines. I think that's really it. Thanks for hanging on for a fairly crazy journey from the 1800s to now. But it's the history of computing and biology together, I think, is a really interesting one. And it's particularly the threads of the women who weave through it, whose stories are often forgotten. Thanks very much, Garry.
Amazing. I love the high concept stuff that you put out there regularly. I would, if I daydreamed, I would love to be like in an environment, I guess, hypothesizing or speculating about what the future would be, particularly in relation to this research. But I'd love to actually ask you a practical way on ways that yourself, CAIDE, and your academic colleagues are working with industry or industry partners, whether by engagement, whether by industry-based projects. What are you sort of doing that comes to mind immediately? And I'd love to know what the opportunities are, because obviously a large part of the reason for doing these engagement events is to put out there some of this research that sometimes sits behind closed walls, expose it a little bit, and engage interest from people that are working in similar things, but potentially without those academic walls there as well. Sorry, I rambled a little bit there.
It's fine. I don't know, Simon, did you want to talk about ethics in industry, which may be your wheelhouse? I'm also happy to jump on it, whatever you prefer.
You go first, Kobe, and then I'll say something after that.
Great.
Okay. I think there are two really interesting angles to that question, Garry. I think the first is that industry has very clearly expressed interest and concern in some of these areas. And over the last 24 months, we've seen an incredible proliferation of AI and ethics strategies, for example, that try to govern and cover the regulation of these materials. I'm also involved with Standards Australia, representing University of Melbourne, looking at governance from a standards perspective, from quite a mechanical international perspective. There are also conversations that are going on in the UN in a number of different areas, including the convention on certain conventional weapons, which has to be the worst title for any treaty body ever. But basically, it's just, most people would know it as a Stop the Killer Robots campaign. So there's another conversation going on in that space, which then feeds back into industry, because industry wants to know that what they're using is not going to be misused, not going to have dual use, is going to maintain trust, is going to have minimal risk. And that comes back to a whole range of considerations that industry has. So our engagement with industry so far has been talking to them about the risks that they are seeing present in their own work, us workshopping some of those concerns with them. But I think what we offer that is really unique, and having worked in this field for quite some time now, is this interdisciplinarity, because this is, all of these issues are not just legal, they're not just ethical, they're not just technical, they're not just policy, they're not just social. As we've seen with the COVID Safe app, it's a perfect example, which we've also written about. It's all of those things. And unless you have all of those considerations, any product that you have will pose risks to industry and or fail. So long-winded answer, but that's
not at all. It was a long-winded question. I thought it was really concise. No, that makes perfect sense. Simon, you were going to remark on that also from your experience?
I think I pick up the same point and say that to address these questions, you do need a range of expertise. So here, I mean, Kobe's got a background in law as well as in technology, and we bring a range of other kind of backgrounds to these questions as well. So I mean, one of the problems, I guess, with addressing these kind of questions is the notion that the ethics can be dumbed down a bit. So, you know, when we're thinking about issues to do with artificial intelligence, one of the other things we're looking at is the use of chatbots in consumer affairs or in health and so on. I think it's important to have that range and depth of expertise, so that we're not just either relying entirely on the technical expertise or relying entirely on ethical expertise, but bringing those kinds of things together, including the law, to address these questions. So hopefully that brings a kind of depth to it, which you wouldn't get if it was just, say, an ethicist speculating on their own, like an ethicist like me, without that technical expertise that you get from colleagues, and vice versa. You know, someone who's an artificial intelligence expert that doesn't have a background in ethics or law or whatever it is. So I think, I think Kobe's absolutely right. I think this is a great area for collaboration and interdisciplinarity.
Can I piggyback one more thing onto that,
Absolutely.
Garry? Which I think one of the things that we often forget, and it's tied in through the theme of the presentation I gave, is that scientists often think about the possibilities of their work, but they don't tend to think about what can go wrong. Novelists do, but scientists just go, we can build that thing, whether it's, you know, the AI that predicts students' outcomes or the algorithm that promotes genocide in Rwanda. These are all things that have real world impacts, but the scientists are building them without thinking about them. So industry is, I think, very aware of some of those risks. And part of our role is even flagging those and thinking about them where they might not be thinking about them. That was all.
No, absolutely fair. You know, every one of these 1 hour webinars, I promise the people attending that it's going to disappear in a blink. And sure enough, it does. So we're getting towards the end. So if anyone has a burning question, please do pose it. Look, I'll ask you one quick question, Kobe. You know, notwithstanding obvious ethical and moral considerations that will arise, if you're remarking on, I say, the last, let's say, technological leap in terms of the manufacturing from the last 5 years, what are you sort of anticipating? Are we talking about some rapid implementation of quantum computing? What are some other factors that you think will just accelerate production or production capabilities?
Is this the what keeps me awake at night question in a different form?
Yeah, probably.
Okay.
Most definitely.
I am really interested by and challenged by not any individual technology, as I mentioned in the presentation, but where the technologies intersect. And I think we're already seeing that. And your question that you asked, Simon, about what's COVID changed in our research, I think what we're seeing is our online lives being expedited. We're also seeing the impact of social media on democracies. Computing has an impact on every single life. So not manufacturing per se, I think, that will change how we're interacting. I think we're already seeing it now, that the digital world that we're inhabiting has very different rules and is governed very, very differently. to the real life world and how that develops, just this week, we've been sent draft legislation that looks at Google and Facebook having to pay money for media content. What is the way that we should be regulating some of these bigger systems? How should we be thinking about them? What impacts they have? These are complex and difficult questions, which, as Simon has said, we really need interdisciplinary teams. So there's no one individual thing, but as these technologies merge and move forward, the considerations get more complex and require greater technical and different levels and different areas of expertise.
No, that makes sense for sure. I've had a question from Lorraine Teague, who was actually, she's been an MC on one of our Melbourne Connect events in the past. So great to see you, Lorraine. She's a smart cities expert and always love having her involved in everything we do. But she's basically expressed a fascinating, succinct threading of the connections between visions of the past and realities of the future. I hope ethics is a part of all computer science courses. If not, why not?
Simon, do you want me to jump in?
Yeah, you jump in, Kobe.
I describe computer science as coming to a moment of reckoning or awareness that a lot of other industries have had. So for nuclear physics, it was the Manhattan Project in Hiroshima. For chemical weapons or the chemical industry, it was Fallujah. Biological weapons, we used mustard gas used in the battlefields in World War I. Computer scientists are only just starting to understand the impact of their work. And when I say computer scientists, there aren't even there's not one whole discipline of computer science. There's computer vision, there's natural language processing, there's AI, et cetera, et cetera. So in short, ethics is required to be taught in computer science courses. So it is a component, but it's a small component, and I think it's not enough. And we are working as a team to raise the profile of that within the school, not just for the students, but also for the staff and on the projects that we're working to think about the longer term implications. It's a really good question, and it's absolutely, we need to be seeing more of this work done.
Yeah, and perhaps I'll just jump in there, Gary, if you've got 30 seconds. Yeah, I mean, I also come from a background of working in medical school, so teaching health ethics to doctors. And over time, it's become recognised that is a really fundamental thing. That you can't train doctors without exposing them to some ethical ideas and ethical ways of thinking, and even some philosophical concepts, really.
Yeah.
Now, I'm not saying that computer scientists and doctors are in exactly the same position, but if it's going to be the case, as it seems to be, that artificial intelligence and other technologies are going to become more and more a part of our lives and to affect us in all kinds of ways, including unforeseen ways, then it seems appropriate that we would also expose the people who are going to be involved in designing those technologies or implementing those technologies to also be exposed to some ethical ideas and concepts, and not just in a dumbed down way, as we were saying before, but in a serious way, in a way that brings it home to such a community of people that these are important ethical questions and not just things to tick off, as it were, but things to grapple with over time.
I promised before that we'd explore a lot of these concepts again in the future, this year, potentially again if we get the time, but definitely for next year. So look, Dr. Kobe Lyons, Dr. Simon Coghlan, I want to thank you so much for participating today. Really appreciate it and love these big concepts that you're putting out there. So thank you.
Thank you so much. And thanks to Zara for the seal. I love the seal.
Yeah, so I'm sharing the graphic recording as we speak. There we go. Sarah, exceptional work once again. Thank you so much. But that's an element or a flavour of the conversation that we had today. We'll publish this out through social media channels and of course as part of the video, which we'll publish on YouTube by next week. So look, my name is Garry Williams. This has been the Melbourne Connect event that connected you material creation. We really appreciate your time. We'll have much more events coming up. You can find them on the Melbourne Connect website, melbourneconnect.com.au. Thank you all so much and we'll see you really soon.
Thanks everyone.
All the best.
Thanks, Garry.
Bye.
Thanks everyone.
Bye.